So in lesson 12.2, we learned how to multiply matrices by hand, but it was so bizarre. We're kind of like, what is even happening? Why does this even work? I think that's going to get answered today when we talk about applications of matrix multiplication. So if you remember back in lesson 12.1, I started off by talking about softball teams and their equipment needs. So, okay, maybe I added an extra team to the list. It doesn't really matter, but it says the following softball teams submitted their equipment lists for the upcoming season. So we've got the different teams and then the different types of equipment. This is how many of each they requested. So it says if each ball costs $4, each bat costs $21, each uniform costs $30, and each coach's jacket costs $18, find the total cost of equipment for each team. Now this is not a pre-calculus question. I absolutely agree. It is a tedious, time-consuming question if we want to do it this way. So in class, we broke all of this up and said, hey, this row, go ahead and find the cost for team A. We kind of divided the work here. I'm not going to do it all, but listen, if each ball costs $4 and team A wants 45, we're going to multiply that 45 by 4. And so, great, we'd get what, 180. Okay. I'll get a calculator in a minute. If we want to know how much we're going to spend on bats, each bat costs $21, so we're going to do 10 times 21. And let's see, uniforms are $30, so we'd take that 18 and multiply by 30. And then the coach's jackets are $18, and so we would take those two and we'd multiply by 18. So again, this is not a pre-calculus question as it sits right now. We would do 45 times 4 plus 10 times 21 plus 18 times 30 plus 2 times 18. And we'd get $966. So team A, the cost $966. And so we would just do that same thing for each team, right? So team B would be 50 times 4 plus 12 times 21 plus 21 times 30 plus 3 times 18, and we'd get 1,136. But again, I did the same thing, times 4, times 21, times 30, times 18. Okay, I know, I'm not going to do them for all 4 teams. You get the idea, right? It's just a lot of repeated multiplication. We can do it. The mathematics is not hard. But can you imagine if we had 30 teams, or if we had 55 teams, right? If we had 20 different types of equipment lists, right? So the idea is the more intensive this data gets, or the longer it gets, the more like of a tedious job this is. So could we be more efficient? Could we use matrices to do this? Well, listen, we just did a bunch of multiplication. Let me go back. We did this times this times this, but then we ended up adding them all together. Now, what we remember from matrix multiplication is that you multiply stuff and add them together. So, let's see what we can do. What would it look like? What would our matrices look like? So, don't forget, when you want to multiply matrices, we have to multiply them in a, oh gosh, sorry, can't talk and write. We need to make sure that their dimensions work for us. So, we said, not only do these numbers must match, but now we're going to start to understand that they must match in value and in meaning. And I'll explain what I mean in a second. Okay? So let's think about the information that we have. On the left, we have types of equipment versus teams. So if we wanted to write a matrix, we could do equipment down the side and teams across the top like we've done here, right? This would be a 4 by 4 because it's 4 types of equipment and 4 teams. So it's equipment by teams. When we look at the second piece of information they gave us, or this sentence here, we know we're talking about the cost per equipment type. So I could turn that into a matrix, right? It would be, we could do this a lot of different ways. We could do the cost and then times the type of equipment, which is balls, bats, uniforms, jackets, right? And so the balls are $4 each. The bats are $21 each. The uniforms, $30. So again, it's just a list, but we can always put a list into a matrix. Okay, so we have two different matrices essentially. Equipment by teams, and then we have cost by equipment. And I really didn't think about it, but I'm going to think about it now. If I want to multiply these together, these inside things have to match. Well, okay, so how they're written right now, I have equipment on the outside. So we're going to switch these. We're going to do teams by equipment type, and we'll do equipment type by cost. Because now we're going to see, and we'll do it, we're going to say, okay, these match, so we can multiply them, and this outside is going to not just give me the dimensions, but the meaning. My resultant matrix will represent the team versus the cost, which is exactly what we're looking for. Find the total cost of equipment for each team. All right, so here we go. We're going to do teams by equipment. So my teams are my rows. So we're going to have to transpose this matrix. That's a new word. Transpose is when we flip the way it's written. And then let's see, we've got balls, we've got bats, we've got uniforms, and we've got jackets. So it's going to be a 4x4. So team A wanted 45 balls, 10 bats, 18 uniforms, 2 jackets. Team B, 50, 12, 21, 3. Team C, I'm just pulling this from the side, 42, 15, 17, and 1. And Team D, 50, 15, 20, and 2. Okay. We would like to multiply that by the cost matrix, which we need to put the equipment going down the side, right? Those are my rows. So balls, bats, uniforms, jackets by the cost, but each of those only has one cost. The balls are $4. The bats are $21. The uniforms are $30, and the coaches' jackets are $18. Now, I absolutely agree that had we kept going down this path, we would have been done a long time ago. That's not the point. The point is, if the amount of information was much more extensive, then this would be a more efficient way to do it. So I'm going to grab my calculator. I need a 4x4. And I'm going to fill that in. Remember to hit your tab button between so that it just moves you around the matrix in, I think, a pretty organized order. And I'm going to multiply that by a matrix that is 4x1. And that's a 4, 21, 30, 18. Oh, geez. There we go. All right. So what did we get? Let me flip sides here. I'm going to write equals. We got a 4x1, and we've got 966, 1136, 1011, 1151. Okay. So first of all, what did we find? We found, remember, teams by cost. So this will be team A, B, C, D, and the column is the cost. Perfect. Look at that. Team A, $966. $966. Team B, $1136. Right? So we set it up and we let the calculator do all of the repeated math for us. And that's why matrix multiplication works the way it does. Okay? Great. Let's take a look at the next one. It says 3 teams participated in a debating competition. The final score for each team is based on how many students ranked first, second, and third in a debate. The results of the 12 debates are shown below. So team 1 had 3 first place winners, 5 second place winners, 4 third place winners. Team 2, team 3. So we could do this the middle school way, right? Team 1 would have 3 people earning 6 points, 5 people earning 5 points, and 4 people earning 4 points. And then we do the same thing. Well, we are going to use matrix multiplication to determine which team won the competition. So let's think about the information we have. We have teams by placement, right? First, second, third. And then in here, we also have information that tells us points by placement. And we should see a word used twice, and it's placement. Those need to go on the inside. Other than that, it doesn't matter. So I'm going to do team name by placement, and I'm going to multiply that by placement versus points. Okay, so we have 3 teams and 3 different placement options, first, second, third. We have 3 placement options and 1 point value for each. All right, here we go. So we're going to do a 3 by 3, and I'm not afraid to just go ahead and label. We've got team A, B, and C, and we've got first, second, third place. We're going to multiply that by, remember placement is my rows, so I've got 3 rows, first, second, and third, and the point value for that. All right, let's go fill it in. Team, oh, look, why am I calling it team A? It was team 1, 2, and 3. I'm sorry. That's my fault. All right. Team 1 had 3 first place winners, 5 second place winners, 4 third place winners. Team 2, 5, 2, and 5. Team 3, 4, 6, and 2. Perfect. Now, first place, remember, earns 6 points. Second place is 5, and third place is 4. All right, so I'm going to grab my calculator, and we're going to do a 3 by 3. And we're going to multiply that by a 3 by 1. By the way, if you go backwards, because we have a column matrix, oh, just kidding, we can't do it that way. I'm thinking of something else. That's okay. We're going to do a 3 by 1 and 6, 5, 4. Okay, so we're not surprised to get a 3 by 1. We're going to jot that down, and then we'll talk about what we just found. 59, 60, 62. My answer, remember, my resultant matrix is teams by points. So team 1, 2, and 3, team 1, team 2, team 3, and this is the points that were awarded to each team. So we let the calculator do the repeated multiplication. So the question was, which team won the competition? Well, let's see. Team 3 with 62 points came in first place. Team 2, I should have better names for these, came in second place with 60 points. And Team 3, Team 1, came in third place with 59 points. Right? So again, I'm not asking you to multiply them by hand. We will use a calculator to multiply these. What I'm really stressing is it matters how you write your matrix. And writing it out in words first is a big deal so that you can make sure that you get these things that match to go in the middle. Because the columns here have to have the same meaning as the rows here.